Professor Stephen Hawking, one of the greatest minds humanity has ever produced, devoted his entire life to studying the deepest mysteries of the universe. His groundbreaking discoveries reshaped the very foundations of modern science. And yet, despite being a man of science, he also left behind a series of prophecies about the future of mankind. Among them was a chilling prediction about the end of the Earth itself. So what were those predictions? And could any of them actually come true? Let's find out in today's story. So fasten your seatbelt as we dive into today's mystery. But first, you'll have incredible luck if you like, and subscribe before this video ends. The history of science is filled with strange coincidences. On January 8, 1642, Galileo Galilei, the man who laid the foundations for modern physics, breathed his last at the age of 78. Exactly 300 years later, on that same date, January 8, 1942, a baby boy was born in the city of Oxford, England. His parents named him Stephen William Hawking. This uncanny coincidence was not just a passing moment on the timeline of history, but a symbol rich in meaning. Galileo was the first to turn a telescope toward the cosmos and question ancient truths. Stephen Hawking, 3 centuries later, would use intellect and mathematics to probe the very origins of existence itself. Both men once stood face to face with doubt, questioned by a conservative academic world, but both would go on to ignite intellectual revolutions from which humanity could never return. Stephen Hawking was born into a truly intellectual family, though his upbringing bore little resemblance to the conventional mold of British middle-class life at the time. His father, Dr. Frank Hawking, was a tropical medicine specialist who had studied medicine at Oxford. His mother, Isabel Hawking, was also a brilliant scholar, specializing in philosophy and political economy, and had likewise attended Oxford. They were 2 individuals of privileged background, yet they lived a life unbound by the usual social conventions. He would later recall a childhood that was both modest and deeply inspiring. An old house, sometimes bitterly cold in winter, yet burning with the fire of contemplation. His father was often away on assignments abroad. His mother, though busy caring for the family, always found time to immerse herself in streams of philosophical reasoning. In that home, no one spoke much about the future, about success or failure, for the only thing that truly mattered to them was a life anchored in deep understanding. It was in that very environment that he was planted with a seed few classrooms could ever offer: critical thinking, boundless curiosity, and a relentless urge to seek answers to questions that had never been asked before. In 1959, at the age of 17, Stephen Hawking entered the University of Oxford. Throughout his 3 years as an undergraduate, he later estimated that he had studied seriously for only about 1,000 hours in total, an average of less than 1 hour per day. But to him, that was enough. It wasn't because he undervalued knowledge, but rather because the Oxford curriculum at the time was far too simple for a mind like his. When a professor once assigned a series of problems from a textbook, Hawking flatly refused to do them, then spent the next class pointing out, one by one, the errors in the book itself. At the age of 21, while most young people were still dreaming of a brilliant future, Stephen Hawking was suddenly forced to confront a devastating diagnosis: amyotrophic lateral sclerosis, ALS, a rare neurodegenerative disease with no known cure, which typically gave patients only 2 or 3 years to live. That blow seemed to bury every ambition, every hope, and every dream he had. And yet, somehow, he overcame it and became one of the greatest physicists in history. In 1965, while searching for a doctoral thesis topic, Hawking encountered a groundbreaking paper by physicist Roger Penrose on the formation of black holes. He decided to collaborate with Penrose to develop what would become the Hawking-Penrose singularity theorems, one of the foundational works for modern understanding of the universe's origins. But his most iconic contribution came in 1974 when he published his theory of Hawking radiation in the journal Nature. In a conclusion that stunned the scientific community, Stephen Hawking proposed that black holes were not entirely black as their name implied. On the contrary, based on the principles of quantum mechanics, he demonstrated that pairs of virtual particles could appear near the boundary of a black hole, called the event horizon. If one particle fell into the black hole and the other escaped, then from an outside perspective, the black hole would appear to emit energy. Professor Dennis Sciama, Hawking's doctoral advisor at Cambridge, once called the 1974 paper one of the most beautiful and moving contributions in the history of physics. In a universe where time and space could bend and twist, Hawking had found a way to bring light back from the heart of darkness. In 1985, while attending a scientific conference in Europe, Stephen Hawking was suddenly struck by a severe case of pneumonia, a seemingly ordinary illness that became life-threatening for a man whose respiratory system had been ravaged by ALS for over 2 decades. Doctors warned that he would not survive unless the breathing tube was removed. To save his life, they were forced to perform a tracheotomy. He survived, but at the cost of losing his ability to speak. Yet, once again, he transcended the limits of his body. A special computer system was mounted to his wheelchair, allowing him to communicate by selecting words through the motion of his cheek, and later with his eyes. A synthetic voice, mechanical and unmistakable, became the voice of Stephen Hawking. In 1988, while the scientific world was still marveling at his work on black holes and cosmology, Stephen Hawking published a book titled A Brief History of Time. Written in clear language yet filled with profound ideas, A Brief History of Time took readers on a journey from Einstein's theory of relativity to quantum mechanics, from the expansion of the universe to the elusive nature of time itself. And more importantly, he helped turn the phrase black hole into a household term. The book sold more than 25 million copies worldwide, was translated into dozens of languages, and became one of the most successful popular science books in history. Following the sweeping success of A Brief History of Time, Hawking went on to publish many other works of popular science, including The Universe in a Nutshell, The Grand Design, and My Brief History. Each book was a tireless effort to bridge the gap between complex equations and the natural curiosity of everyday readers. It's no surprise that he was once called the man who put physics on the living room bookshelf. Chilling predictions about the future of humanity. Although Stephen Hawking was world-renowned in the scientific community for his groundbreaking contributions to black hole theory and cosmology, he did not hesitate to step beyond the confines of the laboratory to pose far greater questions, ones that touched upon the fate of all humankind. In the final years of his life, he was no longer just a theoretical physicist, but had also become something of a modern-day prophet, issuing a series of warnings about potential catastrophes humanity could face in the coming century. What made these predictions so terrifying was not their sensationalism, but the scientific reasoning that made them seem disturbingly plausible. The first scenario he outlined was that of a global ice age by the year 2032. According to Hawking, climate change was no longer a distant threat, but a looming disaster advancing at alarming speed. In numerous lectures, he raised his voice in warning against the growing severity of the greenhouse effect. He predicted that Earth could come to resemble Venus, a planet with surface temperatures exceeding 250 degrees Celsius, ceaseless acid rain, and an atmosphere entirely inhospitable to life. In his view, within just a few short years, a chain reaction of climate events could plunge our planet into a harsh glacial cycle, obliterate ecosystems, and thrust humanity into an era of chaos. His second forecast was that humanity would be forced to leave Earth by the year 2060. With a rapidly growing population, depleted resources, and widespread environmental devastation, Hawking believed that Earth would no longer be capable of sustaining human life. He warned that if we did not quickly identify another planet to colonize, we would eventually face extinction, whether through war, catastrophe, or simple resource exhaustion. He once pointed to the Alpha Centauri system, the closest stellar system to Earth, as a promising candidate for interplanetary migration, and urged scientists to begin investing seriously in spacefaring technologies immediately. The third prediction, and the one he feared most, was that artificial intelligence could become the greatest threat to human survival. Unlike many who feared that AI would rebel or turn evil, Hawking warned that the true danger lay not in malice, but in misaligned objectives. He offered an example. If humans were to build a dam that inadvertently destroyed an anthill, it wouldn't be because we hated ants. It would be because our goals simply didn't align. Likewise, a superintelligent AI with goals different from ours could easily destroy humanity, not out of cruelty, but as a byproduct of pursuing its own ends. It was a vision that was cold, logical, and entirely in keeping with the way a physicist might assess risk. His fourth prediction concerned the rise of a genetically modified superhuman race. Hawking believed that in the future, technologies like CRISPR would be used not only to cure disease, but to enhance intelligence, physical strength, and lifespan. This would create a class of superhumans, individuals capable of upgrading themselves across generations. Once that occurred, he warned, those who remained genetically unaltered would be pushed to society's margins, or worse, possibly eliminated altogether in a world ruled by the genetically enhanced. Finally, Stephen Hawking envisioned an apocalyptic scenario. By the year 2600, Earth would be transformed into a blazing fireball. He explained that unchecked energy consumption, coupled with rampant population growth and the ever-present threat of global war, would push the planet past its limits. If humanity continued to exploit natural resources without restraint, he believed that Earth would soon become exhausted. It would not merely be a matter of rising temperatures. The entire surface of the planet would burn like a massive furnace, erasing every trace of human civilization. To many, these predictions may seem controversial, but they came from a scientist whose calculations of the cosmos had proven eerily precise. So then, are prophecies grounded in science more likely to come true than those uttered by traditional seers? Or was Stephen Hawking, in his own way, also a believer in the mysteries beyond reason? Views on God and the mystery of the universe's origin. Though he was born into a Christian family, Stephen Hawking began, even in his youth, to step out from under the shadow of religious belief and follow the path of empirical thinking. And the deeper he ventured into the nature of space, time, and gravity, the more he arrived at a conclusion that shook conventional thought. The universe was not created by God. In the final years of his life, he articulated this viewpoint more clearly, through lectures, and especially in his book, The Grand Design. Hawking explained that the origin of the universe could be entirely accounted for by the laws of physics. Relying on Einstein's famous equation, where mass and energy are two sides of the same entity, he argued that to create a universe like the one we live in, only two elements are needed: energy and space. But the most intriguing part of his reasoning lay in the concept of negative energy. He illustrated it by saying that if you wanted to build a small hill, you would need to dig out earth from the surrounding area, creating a hole. That hole, he explained, is the negative counterpart of the hill. In a similar way, the Big Bang generated a vast amount of positive energy, but simultaneously created an equal amount of negative energy. This symmetry keeps the total energy of the universe at zero. And that, he said, is why the universe could have spontaneously arisen from nothing, without the need for any divine hand to set it in motion. In a sense, Hawking's perspective bore an uncanny resemblance to the ancient Eastern philosophy of yin and yang. According to this view, all things in the universe are composed of two opposing yet complementary forces: yin and yang, dark and light, motion and stillness. Neither can exist independently, and life itself only functions when the two are in balance. Another argument he offered, one that gave many pause, was his take on time before the Big Bang. Hawking asserted that if the universe had existed in a state akin to a black hole, then time itself did not yet exist. It was only after the Big Bang that time began to flow, and if there was no time, then there could be no before, and thus no one who could have created anything, because there was no starting point for such an act. He concluded bluntly, there is no need for a God to set the universe going. Naturally, for those with deep faith, Stephen Hawking's views may be difficult to accept. But what cannot be denied is that he sought to answer the age-old question, does God really exist? Through the lens of science. And in doing so, he also reinforced the idea that his predictions for the future were rooted not in mysticism, but in rationality. On March 14, 2018, the world fell silent at the news that Stephen Hawking had passed away. Yet the legacy he left behind was far more than equations or cosmological theories. He had become a global symbol of resilience, of a will that rose above hardship, and of an ability to inspire millions across all walks of life. He stood as living proof of a simple yet powerful truth. Though the body may be confined, the human mind can soar to the very edges of the universe. If today's story gave you a moment to reflect on the power of intellect and the resilience to rise above fate, don't hesitate to share your thoughts in the comments below. And if you'd like to continue this journey with us, exploring the lives and stories of the remarkable people who helped shape our world, be sure to subscribe to the channel and turn on notifications. We'll see you in the next video.